Welcome to another video. Today we're going to go over the Trackit app architecture, and we're going to be using AWS to deploy a Django backend. So what will be covered in this presentation? We're going to be building a Django backend locally first, which we've been doing in the last 3 videos. Next, we're going to be migrating from local development to cloud development. And lastly, we'll be deploying our app to a cloud. So first, we'll be building our Django backend locally, which we've been doing the last 3 videos, but as a recap, you need to make sure that our Django application works locally. And so here I am testing it out locally with my virtual environment, and I'm just going to run the server and verify that everything works. Make sure to use get to version your app so you don't lose your history. If you want to revert to an old change, get will help you. And make sure you commit your changes before deploying. Next, we need to migrate from local to cloud. We're going to be using Amazon Web Services as it is an industry standard and it's inexpensive to develop your first app. We're going to be using Amazon Web Services Elastic Beanstalk. AWS Elastic Beanstalk will allow us to auto-scale our EC2 instances, which are our machines that will run our virtual environment. It's going to handle load balancing for us. So it'll handle heavy traffic whenever we get more traffic to our app, when it gets big, and it'll configure our logging and health monitoring so we can see what's going on in case the traffic starts getting 400s. Next, we'll be using an AWS RDS database. RDS is just relational database system, and we'll be using a PostgreSQL database for this. Select your database provider. For us, we're going to be using PostgreSQL database. And we need to update our Django app settings to point to our RDS database host along with a password. Next, we're going to deploy our Elastic Beanstalk environment. First things first, we need to point our Django app to our Elastic Beanstalk domain. So go into settings in your Django app and update the yourdomain.elasticbeanstalk.com and update it with your Elastic Beanstalk environments domain. You should be able to find this in the console. We need to migrate our database from local to cloud. So the way to do this is update the database's dictionary in the settings file and update it with the name, username, password, host, and port. Typically, if you're running a PostgreSQL database locally, then you really just need to change the user, password, and host because your host is clearly going to be in the cloud and it's not going to be local. Next, you need to configure your security inbound and outbound rules on your RDS instance. So you need to go into your RDS instances console and update the bottom 2 inbound rules. The first inbound rule should be given to you for free. The second ones you need to add yourself. And again, in the future, when you want to make your app more robust and secure, you can update these. But for now, since we're testing, these are the rules we're adding for now. And next, make sure to commit your changes and deploy. Hopefully you successfully deploy your app to Elastic Beanstalk. So we're going to go over the current architecture of the Trackit app. The first thing we're going to see is that the iOS client or the desktop client will make an HTTP post request to the IP associated with the Elastic Beanstalk environment. So the client will send something like, I ate 3 ounces of chicken breast and 4 slices of wheat bread. The next thing that'll happen is that the Elastic Beanstalk will reroute the HTTP traffic to the EC2 instance that runs the Django application. Next, the Django application will perform some natural language processing on the incoming plaintext, and it'll map it to a list of dictionaries containing the food name, quantity, and measurement unit. Next, the Django application will iterate over each parsed word and queries each food against an RDS PostgreSQL database instance. Next, the Django application will process the queried results and will package them into a JSON response, serving it up to the client. And finally, the server will return a JSON response with all the nutrition facts of the plain text food items that we sent. So because the natural language processing figured out that we ate chicken breast and wheat bread, and it queried against the database to find the nutrition facts for those quantities, it was able to return us a JSON response with chicken breast, total fat, total carbohydrates, total protein, etc. for all of our nutrition facts information. Again, in this diagram, the JSON response is abridged, so we're going to actually see what the response will look like. So here, I'm going to make a curl request with the exact food I ate in a day, and I'm going to make it look pretty. So as you can see, the result will show all the foods I ate listed out in the order that I ate them and the order in which they were displayed in the plain text, and give me all the nutrition facts related to each one with the serving sizes I included. With this information, I can update the UI to make sure that I can display all the foods in a list in the way I wrote it, and it'll be able to aggregate all the data that I ate. But we'll go over that in another video. Thank you for watching. I hope you made it this far into the video, and if you enjoyed it and learned something new, please let me know in the comments below. If you liked the video, make sure to subscribe. And if you had a better architecture in mind for this project, I would love to hear it. Talk to you soon.